Hey you guys, welcome to the station where we're going to talk about when we factor when a is equal to 1. So when we say a is equal to 1, we are referring to the standard form of our quadratic equation. And we know that the standard form of our quadratic equation is ax squared plus bx plus c is equal to 0. So some ways that this might look when we're using numbers, we could say x squared plus 7x plus 12. Another example of this could be x squared minus 6x minus 7. Or a final example could be x squared minus 9x plus 14. When we are factoring, what we want this to look like is we want to change it from standard form to factored form. So we are going to do each of these examples. When we're doing this when a is equal to 1, so what that means is that there's no number in front of my original x squared term, we are going to use the C tree. So let's take our first example. When we had x squared plus 7x plus 12 is equal to 0. So what I'm looking for are two numbers that will add to 7, add to my b term, and multiply to 12, my last term. So to do that, I'm going to make a factor tree underneath c, my 12. So I'm going to start at 1. I know that 1 times 12 will equal 12, 2 times 6, 3 times 4, 4 times 3. I know that that's a repeated value, so I can stop there. So now that I have all the numbers that are going to multiply to 12, I want to see which one of these factors will add to positive 7. So if I know 1 plus 12 equals 13, that is not positive 7, so we can cross out that set of factors. 2 plus 6 is equal to 8, that is not equal to 7, so I can cross that out. 3 plus 4 is equal to 7. That is going to be my set of factors. So when I rewrite this in factored form, I will have x plus 3 and x plus 4. Now if I want to check my work, what I can do is I can FOIL. So foiling means that I'm going to multiply each of the terms in my first factor set by each of the terms in my second factor set. So I will say x times x, x times 4, 3 times x, and 3 times 4. So let's do that. X times x gives me x squared. X times 4 will give me 4x. 3 times x will give me 3x. And 3 times 4 will give me 12. So when I combine like terms, I will have x squared plus 7x plus 12 equals 0. And I see that this right here is the exact same thing that I had at the beginning. So I'm confident that my factors are correct. So let's recap. First thing we did was we took a look at our equation in standard form. I see that a is 1. There's no number outside of my x squared. So I want to see what multiplies to c, 12 in this case, and what adds to b, which is positive 7 in this case. So we made our C tree, we came up with our list of factors, and then we needed to figure out what multiplied to 12 added to 7. So I looked through each one of my factor sets to figure out which one added to positive 7. When I figured out that that was 3 and 4, I could then plug this into my factored form to say x plus 3, x plus 4 equals 0. This right here is my factored form, but we wanted to check our work by foiling or by distributing. So we said x times x gave us x squared, x times 4 gave me 4x, 3 times x gave me 3x, and 3 times 4 gave me 12. When I combine my like terms, which are the two terms with x's, I know 4x plus 3x gave me 7x. So our final was x squared plus 7x plus 12, which is what we had at the beginning. All right, now let's take a look at another example. So that second one we mentioned was x squared minus 6x minus 7. All right, immediately I notice that this is in standard form because I have ax squared plus bx plus c equals 0. So I don't want to add 7 to both sides. I know that I need to factor. And since a is 1, since I don't have a number out here, I can go ahead and do a C tree. So I know that 1 times 7 will give me 7. There isn't a factor with 2, nothing times 3, nothing times 4, nothing times 5, nothing times 6, and then again 7 times 1. I've repeated this, so I don't have to mention it here. So I now notice that I am adding to a negative 6 and multiplying to a negative 7. So as an aside, if I multiply a positive times a positive, I'll get a positive number. The positive times a negative, I'll get a negative number. And a negative times a negative, I will get a positive number. So if I am adding to a negative and multiplying to a negative, I know that I need to have one positive and one negative. So when I begin to add, let's try negative 1, positive 7. So negative 1 plus 7 will give me positive 6. But I'm looking for negative 6. So let me switch which one I made positive and negative. So let me try positive 1, negative 7, and that will give me negative 6. So this will be my set of factors. So when I rewrite this in factored form, we will have x plus 1, x minus 7 equals 0. So this right here is my factored form. But let me check my work by foiling. So this is where it all comes from. I'm going to say I'm going to foiling or distributing. I'll say x times x gives me x squared. X times negative 7 will give me minus 7x. 1 times x will give me plus x. 1 times negative 7 will say minus 7 equals 0. When I combine my like terms, there we go, we will have x squared minus 6x minus 7 equals 0. And I see that that is exactly what I had in the beginning. All right, you guys, if we were feeling confident, we can go ahead and move on, but I'm going to do one more example for us. All right, in this example, our last one that we mentioned was x squared minus 9x plus 14 equals 0. Alrighty, so I notice that this is in standard form because I have x squared, a regular x, and then no variables. And I see that there's no number outside of my x squared, so this is when a is equal to 1. Automatically, I know I'm going to do my C tree. So my C tree, I'm going to say 1 times 14, 2 times 7, 3 times nothing will give me 14, 4 times nothing will give me 14, 5 times nothing, 6 times nothing, 7 times 2. That's a repeated factor, so now I'm finished. All right, but now I notice that I'm adding to a negative number, multiplying to a positive. So we said earlier that if we had a positive times a positive, we had a positive number. A positive times a negative number will give me a negative number, and a negative times a negative will give me a positive. So if I'm adding to a negative number, multiplying to a positive, I know both of these numbers must be negative. So let's see, negative 1 plus negative 14 will be negative 15. That is not negative 9. Negative 2 plus negative 7 is negative 9. There it is. So when I write this in factored form, we will have x minus 2 times x minus 7 equals 0. Again, we can check our work with foiling. So even though this is our factored form, let's check our work. So we'll say x times x will give me x squared. X times negative 7 will have negative 7x. Negative 2 times x will be minus 2x. And then negative 2 times negative 7 will give me positive 14 equals 0. When I combine my like terms, we'll have x squared minus 9x plus 14 equals 0. And I see that's exactly what I started with. All right, you guys, you may go ahead and begin to work on practice, or if you want to rewatch any of these examples, you may. And if you have any questions, please call over your teacher.